Hi everyone. So today we are going to start the discussion on magnetic materials, the classification of magnetic materials. Okay. So we were talking about magnetic materials in the last 1 week. Okay. So today we are going to discuss the final discussion and final part about magnetic field. The magnetic materials. So first we will discuss diamagnetic materials. So according to how the materials behave with respect to the magnetic field, external magnetic field, we have divided into three parts. The magnetic materials we can classify into three materials. First one, diamagnetic material, paramagnetic material, and then ferromagnetic material. Okay, so I told you before, the last class I told you that is this particular this particular topic, that is a theory topic. So, and our textbook is the best material for that. Okay, so you can easily read and understand the concepts. But anyways, we will discuss one by one. Okay, first we will discuss diamagnetic materials. All of you take your textbook, that would be the better option. Okay, and you can read, you can refer along with me. Okay, so again, so what is diamagnetic material? For example, in a particular material, the orbital motion of electrons would make a magnetic field which is perpendicular to the motion or the plane of the orbit. Okay, the motion in the sense like the electron will move in the orbit, right? So which is perpendicular to the plane of the orbit. So this moment, all of you listen, this moment, magnetic moment, which is actually in random directions. Okay, all of them are in random direction. Do you remember that we have discussed before? Do you remember that we have discussed before in some materials why electric field produced by a current carrying conductor is zero? Because the net electric moment is equal to zero because of the movement in random directions. Alright, so this is the same idea, you can copy it here. So the net magnetic moment is equal to 0. Okay, and when you place this material in an external magnetic field, and what will happen is all the electrons, they'll align in a particular way. So what will happen is some of the electrons will speed it up and some of them will slow down. Okay, when it will happen? And some of them, like you can think like that. So suppose there is an external magnetic field here. External magnetic field is here. So when it will slow down, the electrons they'll also produce magnetic field. So that magnetic field, suppose if it is anti-parallel to the magnetic field, then it will speed it up and the other one will slow down. Okay, so that is the basic idea that you have to understand. Then, like such materials, we can call it as diamagnetic materials, and then in textbook they given. So when we place in non-uniform magnetic field, this is what the uniform magnetic field. So the interaction between induced magnetic moment and the external field creates a force which tends to move the material from stronger field to weaker side, stronger side to weaker side. So that is what is the diamagnetism. That the property is known as diamagnetism. So it means the diamagnetic material repelled by the field or repelled or expelled by the field. Okay. So what are the examples? This action is called diamagnetism and the materials are known as diamagnetic materials. What are the examples? Bismuth is one of the best examples, and water is one of the other examples, and some other examples are also there. Okay, so that is what is diamagnetic material. That is the introduction. You can just read the outline and you can make your own notes. So I have given the assignment, right? Before I have given the assignment, and you have to make the assignment very clearly. And what is the thing? That is what is diamagnetic material. And also, what are the properties? Like we have already talked about the magnetic parameters, right? Magnetic parameters, susceptibility, permeability, etc. So we have to check how these magnetic parameters are matching with magnetic materials. So for example, like we can check one by one. First one, magnetic susceptibility is negative. So magnetic susceptibility of diamagnetic material is negative. Second one, relative permeability, which is slightly less than 1. Mu r is less than 1, but it is very slightly less than 1. Then the magnetic field lines are repelled or expelled, that we have already discussed. Why it is repelled or expelled by diamagnetic materials when it is placed in a magnetic field. Okay, and susceptibility is temperature independent. Susceptibility is not like there is no dependency on temperature. Okay, so that is what is diamagnetic material. And one more small diagram which is given in the textbook. So you can check that if temperature is greater than transition temperature, then diamagnetic materials shows this one. Okay, and if temperature is less than transition temperature, then it shows an effect like that. So it behaves to the external magnetic field like this. Okay, so this effect is known as Meissner effect. So this one word you have to keep in your mind, Meissner effect. Okay, so if temperature is greater than transition temperature, then diamagnetic materials does not have any effect on external electric field, but if it is less, then it has. Okay, so this is what is all about diamagnetic materials, and we will talk about paramagnetic materials in the next video. Thank you.